How's everyone doing today? Isn't this a beautiful hall we're in? It's kind of like a little intimidating, right? Like I should be doing a performance or something. But my name is Karman Khan. I'm the product manager for Inferential and Trainium. And I'm really excited for this session, right? So in this session, we're going to be having some of our customers come in, talk about their applications, talk about their use cases, and share how Inferential was able to help them. And to kind of set the stage here, I want to talk about two AI trends that we see. The first trend is that we see AI kind of being pervasive, right? In all of these different applications, we're seeing AI kind of dominate. And the second trend that we see is that AI is also growing astronomically, right? So the model sizes a few years ago with like AlexNet, they were very small, they were very simple, right? So you just needed to have each, like AlexNet, is it a cat, is it a dog? We ask very simple things from our models. And so today, we're now asking much more complex things from our models. We want them to do more, we want them to be more accurate, and this is causing the model sizes to grow. And this is why at AWS, we've been investing in technologies to make ML faster and make it cheaper as well to deploy. So the solutions that we've been developing, the first solution was what we started with in 2019, which was, it's over here, is AWS Inferential. Inferential was designed to do ML inference and accelerate ML inference and provide the lowest cost to deploy your machine learning applications on AWS. And after that, just recently, a few months ago, we launched Trainium. And the goals on Trainium were the same as well. We wanted to make training models cheaper, and we wanted to make training models faster. And just a few days ago, we announced Inferential 2. And so this is going to be providing even higher performance than Inferential 1, and even lower latencies that you can achieve on Inferential 1 to kind of keep the momentum that we're building here. One of the other aspects that we're designing into our products today is also looking at how do we make machine learning more sustainable, right? So we had a few sessions here at reInvent where we were talking about the sustainability of machine learning products on AWS. One of the ones that, in one of the previous sessions, we talked about how Inferential can lower the energy use for machine learning applications by over 90% when deployed with Inferential. And when using Trainium to train your models, especially the larger models, we can save up to 50% in energy costs as well. And Inf2 is going to extend that. We're seeing, it's early days for Inf2 right now, but we're seeing about 50% higher performance per watt than what is available with G5 instances. And this is all enabled with our Neuron software stack. So we want to make it as easy and as simple as possible to deploy. And so we have native integrations with PyTorch, with TensorFlow, and we're looking to extend that with more ML libraries and partnerships with other kind of popular frameworks out there as well. So some of you might already know this, but Inferential has two major goals in terms of performance and cost. We want to be able to accelerate what you could do with Inferential above what you get with GPU instances today. So here we're looking at 25 higher throughput over G5 instances, and at 70% lower cost. And these ratios will vary based on the models and the use cases deployed. So our presenters today are going to kind of share their experiences and how Inferential's performance and cost savings were able to benefit their applications and the experiences that their customers expect from them. And before we get into our presenters, I wanted to share one kind of story here from our internal teams, Amazon Search. So Amazon Search had some very unique requirements, right? So they service billions of products on Amazon.com and serve hundreds of millions of customers worldwide. And so what they needed to do was have ultra low latency. They had a latency goal of achieving 10 milliseconds for each of their inferences, right? And with Inferential, they were actually able to achieve 3 milliseconds, serving 16,000 inferences in that 3 milliseconds, and able to reduce their cost by 85%. So it was kind of like a triple win there. So even though Inferential has only been around for a few years, we're seeing tremendous momentum. And to kind of share some of these stories, we have 4 presenters here today. And I want to introduce the first presenter, Jesus from Screening Eagle.
Thank you, Conrad. Screening Eagle Technologies was founded in 2019 and provides technology with a mission to protect the built world. We do that by enabling asset owners to apply predictive healthcare that extends asset life and increases the long-term value of their portfolios. Screening Eagle Technology is headquartered in Switzerland and it has over 300 employees worldwide. Our engineers produce hardware, software, and AI models in-house for the full range of products that we sell. Our hardware captures data from the subsurface, concrete structures, and materials in different forms. Geophysicists and other engineers are usually needed to interpret this data, which is produced out of these devices. And this data, it comes in form of radargrams, time series graphics of readings from the device, heat maps, etc., with an aim to protect the built world with AI as an enabler for the captured data. Asset owners can use this data to extend the life of their assets and thus reduce the embodied carbon that they are building. The use of AI enables us to head towards an autonomous inspection paradigm. The main sources of data processed by our AI is either visual, in the forms of plain images and photography, or radargrams, which is scans from the subsurface. Our current use case consists in 2 main scenarios for processing. One is based on batch processing of large files that are captured from camera-mounted vehicles, drones, and automatic inspections. And this is usually very large and is not needed to be processed in real time, so we use batch processing for that. The second use case that we have is near real-time or real-time necessity from our inspectors, which are in field, that they are actually analyzing or scanning some portion of the ground, and they need an instant result. And we cover that through a service that I will describe a little bit later. As you can imagine, to train models like this, you need a lot of data, but unfortunately, tagged subsurface data is not only scarce, but very difficult to obtain. But thanks to Maxwell and his famous equation for electric radiomagnetism, we can simulate how different materials behave and react to a radar pulse, and thus we can build synthetic data sets to train our artificial intelligence. In addition, for other types of data, like photography, that would cover the defects for facades or concrete structures, would generate such data sets based on VFX pipelines techniques to generate them. Our current infrastructures, which I'm showing you in this slide, consists of an hybrid cluster of on-premise and AWS-based infrastructure where we compute our synthetic data sets and train our neural networks. This will change soon to just training everything in the cloud thanks to the introduction of the Trainium family tier 1 instances. We actually orchestrate these machines through a Kubernetes cluster that is sitting on-premise and is connected through an AWS Direct Connect to Amazon. Our inference framework abstracts from making the capture, inference, pre-processing, and post-processing. And it creates those 4 processes depending on the application and executes them in parallel. When the user makes a request, it reaches the service and passes the input to the inference library, which initializes the processing pipeline in order that is displayed here in the slide. And then we return the results to the user. This REST API supports payload and S3 URI. Summarizing the results we obtained by moving from G4 instances to Inf1 is that our transition was pretty transparent to us, and it actually reduced the cost on average by 45 to 50%. Latency improved massively, especially with a smaller input size. But the most dramatic win is that we reduced our cost from $3.47 per million inference to $1.91 per million inferences. And lastly, let's not forget the reduction in the carbon emissions we are all responsible for thanks to the lower power consumption of the inferential chips. Thank you very much.
So, thank you so much to Jesus. Up next, my name is Zach Schmidt. I'm the data science lead at Actuate, and the title of my segment here today is Getting Off the Hamster Wheel, and how we deployed a modern machine learning pipeline using AWS Sagemaker, Neuron, and Inferential. So for this segment, I'll briefly go over where we were when we started this journey, and then next, how we were able to find some cost savings thanks to this new tech. Following that, we'll discuss how we took those savings to scale and how we designed and implemented an automated pipeline. And finally, we'll discuss where we are today thanks to these new developments. So Actuate is a cloud AI software as a service company where we turn any existing security camera into a real-time threat detecting smart camera. Our primary product, as you can see, is weapon detection. And from there, we've also branched out into other products such as intruder detection and loitering vehicle detection. But across our entire suite, Actuate's #1 goal is keeping people as safe as possible. So what does that mean? Well, first, that means sending out alerts as quickly as possible and immediately responding to these dangerous threats, because every second matters in these very serious situations. And second, the sort of benchmark of how good of a job we do is how excellent our artificial intelligence performs. And of course, improving the performance of artificial intelligence over time means constant retraining and constantly spinning the hamster wheel of getting more data, new data, different trying different combinations of the data. And then for training these machine learning models, we're looking at different types of hyperparameter settings or trying different types of neural networks and different machine learning methods in order to get as much performance as we can out of the solution we provide. So the problem with this, of course, and especially with Actuate being a startup and a smaller company, is that developer time is one of our most precious resources. So Actuate was looking for a way to leverage technology to get us off that hamster wheel of constant retraining and redeployment from our data science and engineering teams so that we can send alerts as quickly as possible and so that we can improve the performance of our artificial intelligence model over time. So our first step in this journey took the form of turning to Inferential. So as a cloud AI service, we were initially just on the standard GPU machines in EC2 on the cloud. And so what we did is we just took our primary main model, which is a PyTorch model, and we used Neuron to compile it to optimally run on the Inferential chips, and then we deployed it on one of the Inferential machines. And right away, we saw a cost reduction of 70% in our cloud spend on inference. So already we're seeing, just right out of the box, without too much additional development, massive savings and faster response times. So this opens a lot of doors for us as a company. And obviously, it doesn't take a scientist to tell you that spending less money is good. But what I would like to tell you is how, first, with this improved performance, we're able to accommodate a much wider variety of customer use cases. Whereas if someone had different types of hardware or some kind of network requirements that would make it more difficult to turn any camera into a threat-detecting smart camera, thanks to Inferential, we're now able to accommodate a much wider variety of situations like this. And second, with this reduction in our cloud spend bill, we're able to funnel those funds and channel them into improving the performance of our AI model. So in order to do that, we invested in our training pipeline and tried to streamline our training as much as we can. And to do so, we turned to Sagemaker, where that amount of time of going from labeled data all the way through pre-processing, running training jobs, evaluating, and deploying it, that used to take around 4 weeks of developer time between our data science team and our engineering team. And thanks to Sagemaker, this amount of time was taken from around 4 weeks to around 4 minutes. So now all it takes is for a data scientist of even any skill level to set up a configuration for what kind of run they would like to do on this training job, and let it rip until it's finished, and the data science and engineering teams get to evaluate the performance in the end. Here you can see a snippet of our greater architecture, but here's just the Sagemaker pipeline, where we start with pre-processing this data, then running training jobs, and then evaluating, where we're not just evaluating using standard computer vision and object detection metrics, but running through a proprietary sort of time series analysis to ensure that Actuate is sending the highest quality alerts that we can to keep our customers as safe as possible. And finally, the development stage as well used to be a very hands-on process from our engineering team where every time the data scientists happened to make a new, better model, the engineers would have to start rolling out a deployment to all of our customers, where now we were even able to bake in the Neuron and Inferentia integration into this pipeline. So once we have a trained PyTorch model, through Sagemaker, it gets compiled with Neuron to run on these Inferentia chips. And a deployable Inferentia instance is specified and defined so that at the end of the day, when we take a look at and see which models have performed the best and which is an improvement on the quality that we're currently running in production, it takes just a thumbs up from our teams to launch this new model by clicking the Go button. So Sagemaker was a huge way of freeing up time for our data science team and for our engineering team. And time doesn't just equate to, it's not like we're replacing, of course, the individual contributors' jobs, but in terms of spinning that hamster wheel of deploying and deploying again and deploying another one and training again and training more, now our data scientists and engineers are able to focus on real actionable improvements to our entire structure and our stack and artificial intelligence implementation, for example. So where does that leave us today? Now that we're able to focus on true improvements and not just sort of keeping the lights on and chasing those very precious and important bits of percentage improvements from our AI, but we're now able to focus on research and development. And for example, here, I mentioned previously that out of the box, we got a 70% cost reduction, but through more research and development, more optimization with Neuron, and also spreading this deployment out across our entire suite of all products now here at Actuate, we were able to slice our inference bill by 91% compared to where we were when we began this journey. Next, with Sagemaker, the amount of time it takes for us to click deploy on a new model was shortened from 4 weeks to 4 minutes. And that's not just per model. You can run multiple training jobs from the same configuration when you're setting up a Sagemaker job to run. You could set 10 of them, 20 of them, and then just wait for them to finish and then see if they're ready to be deployed. And finally, this allows our engineering teams to focus on the user experience and the robustness of our service that we provide. And it allows our data science team to perform as scientists and do scientific experiments, find which types of data produce the best models, work on different types of architectures of machine learning models, and not just keep up with the state of the art as it advances, but work on advancing the state of the art ourselves. So thanks to Sagemaker, Inferentia, and Neuron, Actuate was able to successfully get our data scientists and our engineers off of the hamster wheel and see a lot of cost savings along the way, allowing us to focus on true, meaningful improvements to our AI's performance and our customer experience and keeping people safe. So I've been Zach Schmidt from Actuate, data science lead. Thank you so much.
I'm Adachi from a Japanese company called MoneyForward. Today, I'd like to share with you a case study in which we have migrated our service to a system using Inference instances. First of all, let me introduce MoneyForward. MoneyForward is a Japanese fintech company. MoneyForward provides services to individuals and businesses to solve various financial issues. My team is mainly responsible for implementing features that can be solved by machine learning for our services. I will then describe this project. The purpose of this project was to migrate the chatbot service provided by Hitto, a group company, from its existing environment to AWS. The biggest challenge for us was that we only had about 2 months to spend on this migration project. The chatbot service uses a natural language processing model that takes questions from users as input, infers, and returns results. Because of the need to answer real-time user questions, speed of inference processing is a critical factor. In addition, since a model is created for each company, to which the user belongs. The service needed to be able to infer with a large number of models at the same time. This time, we realized the system in the form of a large number of Infer instances running on ECS on EC2. We chose to create tenant ECS services for each of the models and to run a large number of these ECS services within a single ECS cluster. The reason we chose ECS over Sagemaker endpoints was that our team was more familiar with ECS and could take advantage of its strengths given the short deadline. We chose Inferential for three main reasons. The first was the speed of inference execution. The time it takes to perform inference is very important for this chatbot service, as we need to return inference results in real time. The increase in inference processing speed using Inferential was a great benefit to us. Second, the ability to reduce the overall number of instances by adapting Inferential was also attractive to us. The Inferential chip has 4 neuron cores, allowing us to easily deploy multiple models simultaneously. This reduced the number of instances required, which in turn reduces costs. Third, the very easy task of implementing the inference process using the Inferential chip was the most important advantage for us, as we had only a very short time to work with it. We couldn't use Inferential if it was fast and low cost, but took a long time to implement. However, Inferential was very easy to implement and very helpful because it was available immediately after compiling the model and required very few code changes. Finally, here is a summary. We were able to successfully complete this migration project in a short time frame of just 2 months. In addition, costs have been cut in half or less, and inference processing has been accelerated by up to 90% or more. In this project, Inferential was indispensable. Inferential is a proprietary AWS chip, so one might think it would be difficult to use, but it is easier, faster, and less expensive than one might imagine, and I hope to continue using it. We are very excited about Toranium as well in terms of cost and speed. Thank you for listening.
Wow, what an amazing event and what an amazing theater. If you could just stand here and see it, it's really quite incredible. I'm Alex James, Chief Scientist and SVP of AI at Dataminer. I'm going to tell you a little bit about what we do and how we use AWS Inferential. So Dataminer is a real-time information platform. We ingest public data sources from all over the world. We're at over 500,000 data sources right now. This includes images, video, audio, sensor data, text in different languages and formats from all over the world. And our customers are in different verticals: public sector, corporate, NGOs, and newsrooms rely on Dataminer alerts. So what we do is we process this information, we look for important events, and we send out alerts about those events. So events can range from small traffic accidents all the way up to even celebrity news. So anything that's relevant to either public sector or companies in terms of security and corporate risk. As I said, we process over 500,000 data sources in over 100 languages. That includes social media platforms, blogs, web forums, deep and dark web, audio transmissions, and public IoT sensors. Now, one of the things that makes us unique is the amount of data that we have collected over the years, over the more than 10 years of history of the company. So that means we have tons and tons of data that we leverage for building these AI models, which is clearly very, very important. And the second one is because we process different types of data, we use multimodal fusion to detect the events that are relevant to our customers. As an example, which you see on the right, we detected the COVID outbreak back in December of 2019 before anyone knew what it was. So we detected chatter that something was going on in Wuhan, and we sent out the alert to our customers. So that's essentially what we do. And our customers, specifically in the corporate risk space, use our product in different ways. So one of them is corporate security for asset protection, executive protection, travel safety, route safety, et cetera, venue, event security. So events that impact safety of employees, executives, customers, or assets. This also includes reputational risk. So anything that impacts the reputation of a company. That includes, again, brand, executive, third-party brand risk, corporate response, crisis communications, et cetera, et cetera. Cyber risk is a big one. We've seen an increase in cyber attacks and cyber incidents over the last few years. We think this is something that is going to continue to increase. So that's an area where we focus very significantly in detecting things that might impact your business and sending you alerts so that you can act faster. So real time is really critical to us, and scale, right? The types of data that we process, coverage worldwide, et cetera, et cetera. And lastly, business intelligence, so financial services, supply chain, anything that helps businesses stay afloat, where real-time breaking news information is critical. So how does it work? In pretty simple terms, we ingest, as I said, over 500,000 data sources, which include images, video, audio, text, different languages, different formats all over the world, sensor data from social media platforms, from blogs, from the web, the dark web, and from sensors. And then we have to take the sea of information and detect events. So once we get a piece of information, is it junk? Is it not junk? If it's not junk, is it an event? If it's an event, where did the event happen? What exactly was the type of event? So you can imagine from an AI perspective, we have to process tons and tons of data, and we have to build many, many models to do this because the world is changing constantly, right? There are events happening every single second all over the world. I emphasize that it's worldwide coverage. So that includes taking those inputs and processing them one by many different models, and then joining those outputs from these different models to detect what's important and what's not, and then classifying those events into what matters and then sending them to the right customers. So that's kind of roughly how it works. So we process billions of data inputs per day. Inferential has turned out to be really significant for us because it's been a powerful asset in getting this information out faster, in scaling it, in the sense that we've found three major benefits across our portfolio of many different models and different types of data sources. So the first one is that it's allowed us to grow our capabilities by deploying more deep learning models on more inputs. For example, right now with Inferential, we're able to cover twice as many inputs with more languages for approximately the same cost in one of the key NLP tasks, generating more alerts around the globe. Second, we've managed to accelerate existing models. For example, 5x increase in throughput per dollar spent on computer vision models with Inferential. And third, we can leverage the most innovative and accurate models and achieve the same throughput at lower cost. So one of the things with Inferential is that it allows you to pick whether it's latency or scale that you're interested in optimizing for in a particular model. So we can play around with these parameters to achieve what we want for each of the models that we have in our platform. And so in production, to summarize, we've achieved a 5x increase in vision, and in NLP tasks, a 4x to 9x increase. So this is pretty significant. The savings are real. And when we came across Inferential, we wanted to try it out, play with it a little bit. As soon as we started seeing the savings, we're like, wow, this is really changing the way we operate, because it allows us to do things faster, right, at a much lower cost, which when you have a platform like ours at the scale that we have, we're processing billions of inputs per day, every single savings matters quite significantly. So for example, with Inferential, our throughput per second has been increased from 4 to 9 times per dollar spent on cloud resources. Again, a pretty significant increase. And it's been pretty easy to do these deployments. Compiling many common types of deep learning models with the Neuron Toolkit is very straightforward. It provides an estimate of the number of operators that can be accelerated with a network, and quantization is built in. So the runtime can be configured to optimize for either latency or throughput, which allows us to meet the needs of our various workloads very, very quickly. So we're constantly expanding our portfolio, and as you know, in AI, one of the key things is you need to continuously experiment, continuously innovate, continuously evaluate models, test them, tweak them, run them again, and monitor them in production, and that's what we do continuously. And so these savings in costs allow us to expand our portfolio and to do this faster, right? So it's been really instrumental in meeting these compute requirements to achieve these goals. Thank you.